Okay, so we can do three different kinds of operations to edit something. That is insertion, deletion, and substitution. Okay, for the first row, what you have to do is match these characters with these characters. So I have E here, and I have E here. Then what I have to do is I have to check that if I have something like E and E, they're absolutely the same, then I don't have to edit them. This is 0. Okay, E and X. If I have to turn EX into this, only E, I'll have to delete this X. So then the edit distance is 1. Now all of them will be same and just distance will keep increasing. So we can just do 1, 2, 3, 4, 5, 6, 7, and 8. Now one thing might be confusing that this one, I have E here, I have E here. So why did I not consider this? Because they are similar, right? But the thing is, what you're doing here is this EX, is matching this whole thing with just this one. This is a sub problem. This is exhausted. The whole string is just being matched with this single string. You've already matched it one time. It's been used, and you cannot just use it once again. You're not doing it separately. Now, if you're going to the right side, you're matching, this one is increasing, and this is being matched with this one. This is what this row entails. So this is just for the first row. For the next rows, you just have to just figure out these values. So the technique here is if they do not match, all you have to do is just these three values, these two and this one, is take these three values, take the minimum of it and add 1. So the minimum value is here is 0 and just add 1 and 1. In the case that if they are equal, like this x and this x, they are equal. So what you do is get the diagonal value. Just get the copy paste the diagonal value, put it here, and then again it's not matching. So you just get the minimum value plus 1, which is 2. Minimum value plus 1. Now for the third row, so you have E and you have C, which are not same. So 1, 2, 3, minimum value is 1. So put 3 here. X and C not same. Minimum value 0, 1. Each C not same. 0 plus 1. A, C not same. 2, 3, 4, 5, 6, 7. So if they're not equal, what happens if they're not equal? Take these three values, take the minimum of them, which is 2, this one, and add 1 to it. So it's going to be 3. Same goes for this one. Minimum is 1, add 1, that's 2. 1 and add 1 is 2. 1 and add 1, 2. This is equal. So we just copy paste the diagonal value. This is the diagonal value. So we're going to copy paste this. Then what is the minimum number here? It's 2. 2 add 1, 3, 4, 5, 6. I'm just going to fill this up. Plus 1 is 4. 2 plus 1, 3. 2 plus 1, 3. 2 plus 1, 3. 3. And this one is equal. We're going to copy paste the diagonal value. 2. 2 plus 1, 3, 4, 5. For this row, we have a match in the first column. So we copy the diagonal value. And then minimum of them is 3, 4, 4, 4, 3. This one is equal, so we copy the diagonal value. We are at the last row right now. So we take 5 plus 1 is 6. 5, 5, 5, 5. Next one is 3 plus 1, 4. 3 plus 1, 4, 4. Last one is same, D and D matches. We copy the diagonal value, which is 3. I did one mistake here, was that I thought the path should be built from the beginning. The path needs to be built from the end. So the rightmost corner, below, you build your path from here. So what we have here is tree, and you have to trace back where this tree came from. This tree came from the diagonal. So what we need to do is do this. This is where it came from. Similarly, this top one also came from the diagonal. Let's do this. What about this one? This 3 came from T. No, this 3 did not come from a diagonal. As you can see, if you just feel confused, you can just check here. So T and S, they are not equal, so they did not come from the diagonal. It came from here, this 2. So from here, what about this S? This S and S are equal, came from the diagonal value. U and U equal came from diagonal value. A and C, they are not equal, so it came from here. And this one is H. H and C are not equal, but this value did not come from the copy paste. It came from here. This is the minimum value, 0, and we added 1, so it came from here. Then there's X, so they are equal, copy pasted the diagonal value. E and A equal, diagonal value. Now this path has some different meanings. So what I want to show you is, see, this is 3 and this is 3. When it is diagonal and they are equal, what it means is that nothing has changed. They are similar, so you did not have to edit anything. Similarly, you have E and E, they are equal, so we did not have to change them. Now, in the case of T, we're moving this way horizontally. So this horizontal movement means that we are deleting an element. Remember, we have 3 kinds of things: insertion, deletion, substitution. So if we're moving horizontally, and that means that value is decreasing, we're deleting this element. For this case, this means we did not have to edit, again, did not have to. No, this case we had to. We have A and we have C. We deleted this A. In this case, we have H and C. If it is diagonal and the numbers are different, it means that we had to do a substitution. So we found 2 kinds of operation here. One, not actually substitution and deletions. This thing does not have any insertions. Let's quickly do this example to understand insertion. So this is hope. Let's turn this into hopeless. I know, right? This is H and H are equal, so we put 0. And next thing is going to be just 1, 2, 3. Then we're going to calculate, take the minimum value. If they are equal, we take the diagonal value. Not equal, since O and H are not equal, we take the minimum value, add 1. Minimum value, and add 1. These are equal, so 0. Then this is not going to be equal because no O and P there. So just add 1, 2. So P and HO, they're not equal, so take the minimum value, that is 1. 1. So this guy is equal, so take the diagonal value, 0. And not equal, so take the minimum value, which is 0 and plus 1. E will match here. We can do this first. In other cases, it will be 2, 3. 1 becomes 2, 0 becomes 1. Now we have this L. L is not matched with anyone. So what happens here is 3, 4, 5, 4, then 2 becomes 1, becomes 2, 0 becomes 1. There's a match with E here. Other than that, it would be 4, 5, 6, 5, 3 becomes 4, 2 becomes 3, plus 1 matches, so 2 gets copied, just no match with S, so 5 becomes 4, no, sorry, 5 becomes 6, 4, 5, 6, 5, 3, 4, 5, 4, 2, 3, 4, no match again, so 6, 5, 6, 7, 5, 6, 7, 6, 4, 5, 6, 5, find the path right now. E and S are not equal. Where did this value come from? It came from here, this. So if this is like this, a vertical, and the value is increasing, obviously when it's vertical and the value increases, so this means that we are adding something, we are inserting something. So in the previous scenario, we saw this thing that if nothing changes, we did not edit anything. If it changes horizontally, it means that we deleted something. If it changes diagonally, it means that we substituted something, and now we found that vertical. If it is vertical, it means that we inserted something. So if we solve this, it will be like this. So as we can see, this last 4 digits, hope, the hopeless, these 4 words are similar, so we don't have any changes. So 0, 0, 0, 0, there are no changes. But these last 4 words, their insertions. So these insertions can be seen here. So this is how you solve an edit distance algorithm manually.